In this lesson, the two students that you see here, Sasha and Keoni, will create a parabola from its geometric definition. They will use paper and markers, along with any tools they want, like string or a ruler, to make a collection of points that form a parabola.
So today you're going to get to build an important mathematical object called a parabola. Have you guys heard of that before?
Yes, ma'am.
Yeah. Tell me what you know about a parabola.
I know it's on a graph.
Okay.
That's about it.
Do you have an idea what the shape of it is?
It's like a V or a
It's a U. It's a U.
Can you do it with your finger out in front of you?
Like this.
What do you think it's like?
Like a V.
Okay.
It has a vertex.
And you know, it doesn't have to be on a graph. We can do it on regular sheets of paper. But to do that, we have to have a definition that we can use. So can one of you read that out loud?
A parabola is a set of points that are equal distance from a fixed point, called the focus, and a fixed line, called the directrix. Directrix.
Perfect. So you're going to use this definition to create a parabola. And you're going to work together. And I have many tools that you can use. And you can't look inside because you have to request what you need. And then I'll hand you anything that you think you need.
Before Sasha and Keoni can begin making points on the parabola, they have to figure out what the definition really means. First, they struggle with whether or not the focus can be on the directrix.
A parabola is a set of points
That are equal distance from a fixed point. Okay.
fixed point. So
Are you sure that's even? Is that even?
it looks pretty even. They look pretty equal distance.
They're equidistant from what?
Our set point.
Our fixed point. The
But-
focus.
Okay, but they're supposed, each point, like if you point to one of those red ones, let's just, get one finger on that. That point has to be the same distance to the focus as it is to the directrix. So you need to make a directrix.
We have to make a fixed line.
Yeah, you have to put a line
Fixed
somewhere.
line. Okay. Can we use that now?
A set of points that are equal. And a fixed line. So if we drew a line down the middle,
Okay.
maybe? Because
Do it. Draw that line.
Both be the same distance. Or maybe I should use red.
Either one. Want to use black?
Oh, sure.
It wasn't very
So
straight.
if these were spaced out a little more, or better.
Well, if you point to one of them, is that the same distance to the focus as it is to the directrix?
No. It's closer.
I see that.
Okay.
So maybe our focus doesn't have to be on the line, on the focus.
Okay, so that little guy is the focus. And a fixed line is good. This is our directrix. Directrix, yeah. And then we need a set of points that are equal to, so from both. I don't know, those two got to be equal from those two.
When you pointed to that one red dot, what was its distance to the directrix? Can you show me?
It's
That much.
It's distance from the directrix, the line.
Yeah.
Can
So
you move your hand?
If we move the focus right here, it would be the same distance from the focus and the directrix. You think?
Yes, do I got it?
So if that's our focus.
Okay. So changing, do I just leave it?
So now the points are equal distance from the
So
focus.
this one needs to pretend to be out a little bit more?
Yeah, no.
We're pretending.
Yeah, we're pretending. So let's say they're both 2 inches out.
Okay. 2IN. That's not 2. So no ruler anymore?
Oh.
We're
well,
guessing?
okay. So since these are the same distance from the directrix and the focus.
Is it a parabola?
We have 2 points that are equal distance from both of them.
Okay. Do you think that's a problem?
Sure.
Does it look like the thing you expected?
No.
No,
Why didn't that work?
because
Oh,
I have to think about it again. Okay.
because then it would just turn into a line instead of a parabola.
Why would it turn into a line?
Because the only way that they would be able to be the equal distance is in a straight line. You can angle it off.
Did you get what Sasha is saying? She thinks that it's not okay to put the focus on the directrix. Essentially, she's saying that if the focus is on the directrix, then all the points that she and Keoni could create that fit the definition would form a line instead of a parabola. For example, one of the points they found was 2 inches from both the focus and the directrix. Sasha said that the only way for other points to also be the same distance from the focus as they are from the directrix is for them to be in a straight line, which she showed with her hand. She seems to have in mind that if you put a point, say, 3 inches from the directrix and the focus, or 1 inch from the directrix and the focus, then these points, and others like them that fit the definition, would form a line instead of a parabola. Sasha and Keoni decide to start over, but Sasha still is unsure if they can put the focus on the directrix.
Or
Want to start over?
whatever. Sure.
So our directrix is going to be horizontal this time.
Okay.
And our focus is going to be
Is it
right
going to be on it again?
again.
What do you think about that, Sasha?
Does it have to be on it? Or can it be like, ooh, and then have it be like in the middle? You know, I don't know. You know what I mean?
You mean
You know what I mean? Well, not like in the middle, but you know, like, does that one have to be on the line, or can it be like, ooh?
Well, when I said that they're equal distance from the fixed point and from
The fixed line.
the fixed line, I'd expect them to be on the same distance.
Okay. We'll
Let's try
one
this
first.
case, and then maybe we can try Sasha's case.
Okay.
And then we have our
Making it up.
we
What'd you
have
make it at?
our set points right there.
So can you tell me what the distance is from one of those points to the focus and to the directrix?
It is roughly 4.5 inches.
And that's the distance to the focus?
That's to the fixed point and then to the fixed line.
What is, so you think that's the same? Now look at what she's doing.
That way.
And then I kind of heard 2 different possible distances that the red point is to the line. So will those distances be the same?
Looks 4.5 to me.
Now bend it to
it's
the
not.
other point.
But now it's
Is it the
going to be
same?
more.
Look at that.
So this is a really important idea. What do you think the distance from a point to a line is? Which one should we use, or can we use any of them?
Okay, so then we're going to compare it with, instead of with the ruler, we're going to use the string. Is that
And you're trying to figure out what?
which distance we're going to use?
Okay.
Like,
Let's see.
like which one's right? So that's the crooked one, not the straight. Right?
On the straight.
Not the straight. Yeah. Is that straight? Straight enough.
Okay.
Okay, go.
So let's see if it's the same distance. I can't tell.
Are they close to each other?
Yeah, they're really
Pretty
close.
Let's try this. I think what you're doing is very smart. Keoni, can you make a red dot that's even further away from those 2?
Even further.
Yeah.
Yeah, so then it's going to be like a more.
Over here.
Yeah. And then test this idea
There we go.
about the distances again. Like, is the distance from that to the focus the same as it straight down to the directrix?
Okay, so now that was like whoosh. And then,
Yeah, so this string looks like it's going to be longer. Than the one. See?
Sasha and Keoni have figured out something very important. If they measure the distance between a point and a line along a segment that is at a right angle to the line, then that distance will be shorter than the distance of any other segment connecting the point and the line. With this new discovery, Sasha and Keoni are ready to create a collection of points that form a parabola, which is exactly what they do in the next episode. They will also start with a new drawing, and this time they place the focus so that it is not on the directrix.